Picture the entire human race, billions of people, cities worth of culture and technology, lifting off from Earth and setting course for a single, faint red star. Our destination is Proxima Centauri b, the closest known exoplanet to Earth, circling the small red dwarf Proxima Centauri just over 4.2 light-years away. It sounds like the ultimate new home fantasy, a planet roughly Earth-sized, sitting in its star's habitable zone where liquid water might exist. But what would it really take to move everyone there, and what would life be like if we succeeded? Even with a perfect plan, distance is our first giant obstacle. 4.2 light-years means nearly 40 trillion kilometers. Our fastest existing probes, Voyager or the New Horizons spacecraft, would need tens of thousands of years to reach it. To move an entire civilization, we'd need technology far beyond anything today. Perhaps fusion drives, antimatter engines, or giant laser-pushed light sails. At a hopeful 10% of light speed, the trip still lasts over 40 years, and building vessels large enough to carry billions of people, or thousands of generation ship habitats where families live and die en route, would require a space-based industrial revolution. Before we even leave the solar system, we'd have to mine asteroids for raw materials, build orbital cities, and master life support on an unprecedented scale. And consider energy. Accelerating just the mass of humanity's essentials, food, water, habitats, and the people themselves, to a fraction of light speed demands more power than our planet currently produces in centuries. This isn't a single rocket launch, it's an era of engineering unlike anything in human history. Let's imagine we've made it. After decades or generations in deep space, our fleet breaks into orbit around Proxima Centauri, a dim red star a fraction of our sun's mass. Immediately we face new physics. The star flares violently, releasing intense stellar radiation and X-ray bursts that can strip atmospheres and fry electronics. Proxima b orbits only about 7 million kilometers from its star, 20 times closer than Earth is to the Sun, so a year there lasts just 11 Earth days. Astronomers think the planet is likely tidally locked, meaning one side always faces the star in permanent daylight while the other side sits in endless night. Those conditions create an alien environment. The day side could be blisteringly hot under constant red sunlight, while the night side might be frozen under perpetual darkness. The most livable region would probably be the terminator zone, the thin twilight ring between day and night. There, temperatures might hover near the range for liquid water, if an atmosphere and oceans still exist. Before landing, we'd need to confirm that Proxima b even has a stable atmosphere. Powerful stellar winds may have stripped it away. If it lacks air and water, we'd be building sealed, pressurized colonies from the start, importing or manufacturing our own atmosphere using mined ice or chemical processing of rocks. Gravity would feel familiar. Estimates put surface gravity at something close to Earth's, perhaps a little stronger. That's good news for our bones and muscles after years in space. Settlers would see a dim crimson daylight. The sun in the sky, Proxima Centauri, would be a small ruby disk far brighter than our full moon but far dimmer than Earth's sun. Plants from Earth couldn't photosynthesize efficiently under red light. We'd engineer new crops or rely on indoor hydroponics under artificial lamps. Because of constant stellar flares, cities would need radiation shielding. Colonies might be dug beneath thick layers of rock or built beneath domes coated with protective materials. Energy would come from nuclear fusion, geothermal taps, or carefully managed solar arrays built to withstand bursts of radiation. Timekeeping would change. With an 11-day year and no normal day-night cycle on the twilight ring, humans might abandon the 24-hour rhythm entirely, creating artificial light cycles to maintain health and sanity. Moving billions of people to Proxima b isn't just a technical feat, it's a social experiment on an epic scale. Entire cultures would leave Earth behind, perhaps never seeing the blue planet again. Generations would be born and die on the journey, growing up with no memory of open sky or natural sunlight. Governments and economies would need to reinvent themselves for an interstellar diaspora. Who decides who goes first? How do you maintain law and order in a fleet traveling for decades? What happens when people who have lived their entire lives in space finally step onto a new world with alien skies? Even after arrival, settlers would face psychological challenges. The isolation of a sky lit by a dim red sun, the constant need for radiation shelters, and the knowledge that Earth is 4 light-years away, too distant for quick communication or rescue. What happens to Earth while humanity migrates? Earth would continue without us. Perhaps a fraction of people stay behind. Perhaps climate change, resource scarcity, or some catastrophe drives the exodus. Over centuries, the home planet could rewild, cities crumbling back to forest and ocean. Future travelers returning from Proxima might find Earth transformed into a lush wilderness or a carefully preserved cultural monument. If we succeed, humanity would become a multi-stellar species, no longer tied to a single star. Proxima b could serve as a stepping stone to other systems. Alpha Centauri A and B lie nearby, offering further real estate. Over millennia, our descendants might spread through the galaxy, carrying Earth's legacy with them. But life on Proxima b would never be a second Earth. It would be a world of constant red dawn, of storms driven by a restless dwarf star, of societies adapted to enclosed habitats and underground cities. We would change to match it, biologically, culturally, perhaps even psychologically, until the word human means something broader than it does today. Relocating all of humanity to Proxima b is one of the boldest what-if scenarios imaginable. It demands technology we don't yet possess, patience across generations, and the will to leave our cradle forever. Yet it also captures something essential about our species: the urge to survive, to explore, and to keep reaching outward. If someday we truly set sail for that faint red star, we will carry with us the oceans, the music, the languages, and the memories of Earth, turning a distant planet into a new chapter of the human story, under a sky that glows forever crimson.